Well, congratulations, because we've made it to 8.6, the last section of chapter 8. And this is about solving rational equations. Okay, and I'm going to show you a way to solve that you'll probably be very familiar with. That's solving by cross-multiplying. Okay, so one thing, if you remember, if you had like an equation like x over 15 equals 1 over 5, right? Do you remember that? And you remember back when you were learning algebra, you'd solve this by first multiplying 15 and 1, and that's 15, and setting that equal to 5 times x. So you've got 15 equals 5x, then you divide by 5, so then you'd have x equals 3. And that's how you solved those kind of equations. Well, we're going to do something very similar today, but we're taking it up a level because this is Algebra 2. Okay, so we can start, let's start with the first example. Okay, we're going to do, let me pick a fun color here. So we are going to multiply 3 and x minus 7, and don't forget you're multiplying 3 in the whole quantity, x minus 7, so you're probably going to want to put that x minus 7 in parentheses, and then that's going to equal 2 times 5x. So that, if we distribute the 3, we have 3x minus 21 equals 10x. Okay? Then if we continue that up here, combine our like terms, so we subtract 3x from both sides. We have negative 21 equals 7x. Divide by 7, so we have negative 3 equals x. Okay? And let's see, I'm going to insert some space here. It's always good to check our solution, so let's check, does negative 3 work for this particular problem? So we have 3 over 5 times negative 3 equals 2 times negative 3 minus 7. So does that work? So that would be 3 over negative 15. Does that equal, and we'll put a question mark because we're checking it, 2 over, let's see, negative 10. So let's check again. 3 and 15. Let's see, we can divide 3 by 3. That's 1, and 15 by 3 is negative 5, so that's negative 1/5. And 2 over negative 10, that's also negative 1/5, so our solution checks out. Okay, let's try the next problem. So we're going to cross multiply again. This gives us negative 4 times x minus 3, and that's going to equal 5 times x plus 3. Okay, distribute the negative 4, so that's negative 4 times x plus 12, and that equals 5x plus 15. Going so smoothly. Combine our like terms, so we want to add 4x. So we have 12 equals 9x plus 15. We can subtract 15. So that gives us negative 3 equals 9x. Then if we divide by 9, and I'm going to add some more space here. Always adding more space, I feel like. Okay, so we have negative 1/3 equals x. Okay, and I'll let you go ahead and check that on your own. Okay, one more example problem. And if you don't need another example problem, feel free to fast forward here to the next problem. So this would be x times 2x plus 5 equals 11x plus 8. Okay, so then x times 2x is 2x squared. X times 5 is 5x. That equals 11x plus 8. Notice we have an x squared. This is a quadratic equation. To solve this, we're going to have to set everything equal to 0. So we're going to have to subtract 11x and also subtract 8. So that's going to give us 2x squared 5 minus 11 is negative 6x minus 8, and that's going to equal 0. Okay, we can either solve by factoring at this point or solve by using our quadratic formula. I'm noticing that 2 and negative 6 and negative 8 are all even numbers, so I'm going to take out a 2. That leaves x squared minus 3x minus 4. Okay? Right away, we can divide by 2. If we divide both sides by 2, that just says that x squared minus 3x minus 4 equals 0. Okay? So to solve this, we can factor. I'm looking for factors of negative 4 that add up to negative 3. So that's x minus 4 times x plus 1 equals 0. If I set each of those equal to 0, that means x minus 4 is 0, so x equals positive 4, or x minus 1 equals 0, so x equals negative 1. So those are my two solutions. Now, one of these might not work, so we're going to have to insert these back into our original equation and see if they work. Okay, so I'm going to look at 4. Does 4 work? So if I have 1 over 2 times 4 plus 5, does that equal 4 over 11 times 4 plus 8? So that would be 1 over 8 plus 5. Does that equal 4 over 44 plus 8? So I'm looking at, does 1 over 13 equal 4 over 52? Okay, and in fact, 4 goes into 4 one time, and 4 goes into 52 13 times. So 1 over 13 does in fact equal 1 over 13. So x equals 4 is a solution. Now we have to check, does x equal negative 1? Is that also a solution? I'm just going to use another color here. So I have 1 over 2 times negative 1 plus 5. Does that equal, negative 1 over 11 times negative 1 plus 8? So are those equivalent? On the left-hand side, we have 1 over negative 2 plus 5. On the right-hand side, we have negative 1 over negative 11 plus 8. So that is 1 over 3, and I'm checking if that is equivalent to negative 1 over negative 3, which is the same as 1/3. So this solution, in fact, checks out. So both solutions work in this case.